Okay, students, we will discuss backtracking approach of designing the algorithm. In backtracking approach, when we design algorithm, it considers all the possible combination to solve any computational problem. Okay, when we try to select every possible combination, then it is known as brute force method. That means backtracking uses brute force method to solve any computational problem. And the second property we can say, it applies a brute force, means all the possible combination but within a systematic manner. If we apply the brute force approach in a systematic manner, it goes under the backtracking. And secondly, when we use the backtracking, it moves in DFS, means depth first search manner, with or without constraint. With or without constraint, right? For example, suppose if we consider three students, namely two girls, G1, G2, and one boy, okay, B1. We have three students like G1, one girl, second girl, and one boy, and we have 3 chairs, okay, and we have 3 chairs. So in how many ways these 3 students can sit in these 3 chairs? The total ways will be factorial n, that is factorial 3, and factorial 3 is 3 into 2 into 1, that is approximately 6. Okay, 6 ways. Okay, now suppose now how can we make each student to sit in the chair? Suppose at the starting we are here, we will discuss is through the state space diagram. State space diagram, okay, state space diagram. Okay, initially we have a chair, one chair, right, and we make G1 to sit here. Okay, now G1 has taken place at the first chair. Now suppose G2 has taken second place, and now at the third chair we have boy B1. Okay, this may be the option. Suppose B1, boy B1 is removed from this chair. Okay, we come here, but we have no option, so we go one step back, we are here. Okay, when we are here, that means G1 has taken its place at the first chair. Now on the second chair we can make the boy B1 to sit. Okay, now at the second chair boy has taken its place. Now at the third one girl G2 can take her place, right? And in secondly you can remove G2, you can remove B1, that means come one step back at the place chair 2 and come here at the place 1, and here you can remove girl 1. Now no one student has taken place, so at the first chair now you can make G2 to sit. Okay, G2 sit at the first place. Now for the second chair boy B1 can take place. Okay, and when second place is full, now third place is remaining, and we have girl G1. Okay, G1 can take place. Now you can remove G1 at the third place, and you can remove boy at the second place, And now at the second place, now Jeevan can sit. Girl, Jeevan can sit. And at the third chair, boy B1 can sit. Okay. Now remove B1 from the third chair, G1 from the second chair, and G2 from the first one. Again, we have 3 places empty. So at the first chair, now B1 can be sit. Okay, when B1 is already taken place, then for the second place, girl G2 can take place, and then girl G1. Okay, now similarly remove G1, remove G2. At the first place, B1 has taken its place. For the second place, maybe G1 can take place, and then the last third chair, on the third chair, G2 can take her place. Okay, now these are the total ways. Ways 1, way 2, way 3, way 4, way 5, and way 6. 1, 2, 3, 4, 5, and 6. 6 ways. So these are the 6 ways. Total number of ways. These students can be sit in 3 chairs is 6, and how they can sit in these ways: G1 G2 B1, G1 B1 G2, G2 B1 G1, G2 G1 B1, B1 G2 G1, B1 G1, and G2. So this is a simple example of backtracking, how we go one step back and one step back and then search for the other option. Okay, if there is an option, we go through the path and until we get the solution. If it is not possible to get the solution, then we again come back one step and then go beyond. So this is a kind of backtracking. This is a simple backtracking, but we can apply the constraint on it, and we can discuss it in the next example, that is n queen problem. Okay, now the problems that can be dealt, problems using backtracking but with some constraints. Okay, first is n queen problem, second is sum of subset problem, and third is M coloring problem. All these can be solved using backtracking.